Good day, friends. In the series of where videos, which is an initiative by Council of Engineers and Valuers, we have already launched two videos which were uploaded on its website, and continuing with that, we have this third video, which is based upon cost approach method. This is the first video of that approach. In this video, we will be discussing basics of cost approach. Only that part which is related to basics of cost approach. We will divide the cost approach into three videos so that you are able to understand the topics easily within short possible time. So this is the type of videos in which you can teach yourself valuation methods, different valuation methods. So as far as syllabus is concerned, syllabus for cost approach to value, you have to learn methods of cost estimates for buildings, life of building, such as economic life, physical life, legal life. Then what are the factors that affect the life of a building? Then what is total life, age of the building, and estimating future life, how you can estimate the future life of the building. Then you have to learn various methods of computation of depreciation, functional, technological, and economic obsolescence. Then you have to learn reproduction cost, replacement cost, depreciated replacement cost, working, adopting DRC. DRC means depreciated replacement cost as value subject to demand and supply aspect. Then you have to learn land value by market approach and building value by cost estimation method for owner occupied bungalows, factories, and public buildings. The weightage of this approach is 7%. But in the first video, we will be dealing up to only uh, total life age and estimating future life. So these three things will be discussed: methods of cost estimates, then life of the building, and then total life age and estimation of future life. That means only we will be dealing with only the basic things which are necessary for understanding this cost approach. The first thing is method of cost estimates of building. These things have been taught to you in your engineering or architectural syllabus. This there is nothing new in this. There are different methods for calculation of estimates. So whenever you are doing valuation based upon cost approach, then calculating the value of building, it becomes necessary to assume cost of construction. So in cost when cost approach, there are two things. One is cost of the land and then the cost of construction. So in cost of construction, basically you have to estimate the value of the constructed part. So it becomes necessary to assume cost of construction, or what is primarily known as prime cost. So there are different methods to for calculating or the estimate cost estimate of the building. Preliminary cost estimate, plinth area cost estimate, cube rate cost estimate, approximate quantity method cost estimate, detailed cost estimate, revised cost estimate, supplementary cost estimate, annual repair cost estimate. So basically, this primarily preliminary cost estimate. What is this preliminary cost estimate? So whenever any project is to be started, so on then only preliminary cost estimate is made at the start, so as to estimate to what is the budget required for this project. So this estimate, this is also called abstract cost estimate or approximate cost estimate. So what we do in this case, we we take the examples of our, or we take the similar type of project what was the cost on the similar type of project in the nearly completed recently completed project. So in this estimate, what we do, the approximate cost of each important item of work is displayed individually. So basically what we do when you are doing, let us suppose you are doing display detailed cost estimate, and at the end of the detailed cost estimate, what you prepare? You prepare an abstract of cost. So basically this is also an abstract of cost where individual items are displayed and utility of each item of work is displayed. The item of works include cost of land, cost of roads, electrification, water supply cost of each building, etc. And the second method is plinth area cost estimate. This is the basic method which is mostly used by the valuers while doing valuation based upon cost approach. So in this case, in this method, what we do, first of all, we calculate the plinth area of the building of which you are doing valuation. Then you have to consider the prevailing plinth area rates in your area. Generally, what we do, we take the plinth area rates as prescribed by the state WD department for preparing rough cost estimate. So every state has given its own plinth area rates. You have to consult these rates, and then you have to make adjustments in according to the specification. If there is some difference in specification of the subject building of which you are doing valuation and the specification as prescribed in plinth area rates, to make adjustment for that. So by knowing the plinth area rate and the plinth area of the building of which you are doing valuation, you multiply both of them. That will give you the cost of construction or estimated cost of construction of the building. So for example, if we require the plinth area estimate of 100 square meter in a particular locality and plinth area rate of the building in the same locality is rupees 2000 per square meter, then plinth area estimate 100 into 2000, it will be rupees 20 lakh. So what we do in this case, in, in this estimate, open area, courtyards, etc. are not included. You remember, open areas and courtyard, etc. are not included in this plinth area. So if the building is multi-storied, the plinth area estimate is prepared separately for each floor. Next one is some of the limitations of this method are, in this case what we do, basically only plinth area means length and width is taken into consideration. So plinth area rates are mostly based upon for a particular height of the building. If the height of the building changes, you cannot use that plinth area rates. So here ceiling height, because ceiling height is not taken into consideration in this method. So it maybe if the subjective building of which you are doing valuation has different height, then the available plinth area rate for a particular specific height, so you cannot use that plinth area rate. Second thing, if there are very large openings in the building, we have to make adjustment for them. Then next method is cube rate cost estimate. In this cube rate cost estimate, what we do in this case, volume is taken into consideration, means by multiplying plinth area rate with the height of the building, you can calculate the volume of the building, and if the volume rate of the building is known to you, you can calculate the cost of construction of that building. So this method of estimation is accurate than plinth area method because you are taking all the three dimensions into consideration. So rate per cubic meter is taken into consideration based upon the cost of similar type of building situated in that location. Next is approximate quantity method of cost estimate. In this case, what we do, we calculate the total length of the walls of the structure is, and then this length is measured by rate per running meter. See here, we are using rate per running meter, which gives you cost of the building. The rate per running meter is calculated separately for foundation and superstructure. So in case of foundation, rate per running meter is decided by considering quantities such as excavation, cost, brickwork, and brickwork cost up to place. While in superstructures, we consider quantities like brickwork in the for the walls, woodworks, floor finishing, roof slabs, etc. for deciding the rates per cube running meter. So see here in plinth area rates you were using plinth area means two dimensions length and width. In cube rate cost estimate you are doing considering all the three dimensions length, width and height of the constructed structure. And but in case of approximate quantity of method of cost estimate you only take the length of the building into consideration. Of course, for superstructure and for a substructure, the rate will be different. Then the basic detailed cost estimate. Detailed cost estimate is the most accurate estimate. It gives you the most accurate estimated value of the structure. And here in quantity of you calculate quantity of each item and then you multiply that quantity with the item rate which is given by the CS for common schedule of rates of state PWD, or you can take CPWD rates for calculation the rate of to take the rate of each quantity. Then where cost of each quantity is calculated, then they are added up, then to that you add approximately 3 to 5% for contingencies and miscellaneous charge expenditure. So for this, what you need for preparing, first thing you need general specification. Until and unless general specifications and detailed specifications are not known to you, you cannot prepare detailed cost estimate. And then you must have drawings, layout plans, elevations, sectional views, detailed drawings, etc. Then you must have with you the calculation of RCC structure. If it is RCC structure, then you must have the RCC design for design of foundation, beam, slabs, etc. And if it is a steel structure, you should know have the all the details of design of columns and the beams, and then type of roof which you are providing, details of each and every item, and then you must have with you schedule of rates with you. By using these detailed specification, general specification, drawings, design and calculation schedule of rates, you will do calculate each quantity, then you will calculate the value, the cost of each item by using schedule of rates. Then from that you will prepare a report. That is most important thing which you have to do. So all these things are the part of the detailed estimate, and then revised cost estimate. So during the construction of the project, if there is a change in the estimated value by an amount, if by an amount, if it is more than 5%, so let us suppose the cost of estimated cost of construction was 1 lakh, and if it is more, it increases during the construction by more than 5%, then you have to prepare a revised cost estimate to take permission from the concerned or competent authority. So you have to take permission to continue with this estimate. So revised cost estimate is prepared when the estimated cost increases by 5% and more during the construction of the project. So this may be due to sudden increase in cost of material, cost of transportation, etc. So let us suppose you are doing the project work of a bridge, and you know in the bridge a lot of quantity of steel is required. If the rate of steel all of a sudden increases from say rupees 65 to 85 or 75 rupees, the cost of the project will increase many folds. So then you have to prepare a revised cost estimate in that case. Then is supplementary cost estimate. So a supplementary cost estimate is that during the construction of a project, you all of a sudden find that another thing, another building or another room is to be added, which is required to be added. For that, you have to prepare a supplementary cost estimate. So you will prepare the estimate sheet, and it should consist of cost of original estimate as well as the total cost of work, including supplementary cost of work for which sanction is required. Then annual repair cost estimate. So basically, this is generally used in government department where, such as, let us suppose we take the example of railways. They have a number of buildings such as station buildings and staff quarters and many other buildings which required to be maintained regularly, and for that some annual repairs are to be taken up each year. So for that, annual repair cost estimate is prepared to take sanction from the competent authority at the start of the financial year. So the annual repair cost estimate is called annual maintenance estimate, which is prepared to know the maintenance cost of the building, which will keep the structure in safe condition. This including whitewashing, painting, minor repairs, etc. They are taken into consideration while preparing annual repair estimate of a building. Then life of the building. So there are basically three types of life: economic life of the building, then physical life of the building, and legal life of the building. Economic life, it is a period life during which a building remains economically viable. So let us take the example of a car. If it is a new car, during, let us suppose, after 5 or 7 years, after 7 8 years, it require regular maintenance, and the cost of maintenance is such that if you sell that car and buy a new car, that will be more economical. Similarly, in the case of building, if the cost of maintenance is more than what if you have a new building in place of that, then it is called that its economical life has come to an end, beyond which it cannot be used economically. So it is not economically viable. So the period during which the building remains economically viable and contribute to the property's value. So this is most important thing, because when you do well properties valuation, you have to check so whether it will be economically viable to use that building, and then what another thing you have to check is that whether the condition of the building is such that it is adding to the property's value. So this is economic life. It means the life beyond which the building cannot be used economically viable. Viability of the building is has come to an end. So the factors which will affect the economic life are market demand, functional obsolescence, and economic condition. For instance, a building might be in good physical condition but may no longer be economically viable if it does not meet the current market demands, or if it maintaining it becomes too costly. So this is important thing. If maintaining it becomes too costly, for example, a commercial building have an economic life of 30 years, after which it may be more profitable to redevelop the site. Next is physical life. So this is the total period of the building physically last before it deteriorates beyond repairs, means beyond which you cannot use it safely. Because let us suppose the economic life of a building has come to an end, but it still can be used safely. It may be that it may not be economically viable, but it can be used safely. But a time will come when it is not possible to use it safely. It may harm the inhabitants anytime. So we say that its physical life has come to end, that it deteriorates beyond repairs. So what are the factors which may affect the physical life? They are construction quality, maintenance, means better the construction quality, higher will be the physical life. Better the maintenance, higher will be the physical life. If the environmental conditions means the building is not subjected to extreme weather conditions, and it will have more physical life. And material, if the better materials are used, it will have more physical life. So regular maintenance can extend the physical life of the building. So a life of the building, well maintained residential building, we have physical life of in 50 to 100 years. Then is legal life. The legal life is the period during which a building is legally allowed to exist based on zoning law, building codes, or other regulations. So means what factors may affect the legal life? Changes in zoning laws, building codes, and legal requirements. So let us suppose you have a commercial building in a commercial zone, but all of a sudden the zone of that area is changed from commercial to residential. So though the building is in good condition, but it cannot be used legally because its zoning has changed. Similarly, let us suppose you have a building which was given on lease for 30 years. A plot was given as a given to the lessee. The lessee constructed a building, and he's allowed to use that building for 30 years, as the lease period was 30 years. Now, in the lease deed, it was written that the lessee will dismantle the building and will return back the open land or vacant land to the lessor. So, though the building may still have certain life left at the end of 30 years, but because as per the lease deed or lease agreement or lease document, he has to demolish that building and return the vacant land, vacant open land to the lessor. So we say that its legal life has come to an end. So this is legal life, means a time beyond which you cannot use it legally as per the building codes or zoning laws or other legal requirements. Then what are the factors that affect the life of the building? So for one thing is quality of construction. So better the quality of construction, better the materials used, better the workmanship, better will be the quality of construction, and that will also affect the life of the building. The life, economic life and physical life will be more if the quality of construction is better. And the most important thing is upkeep. Even though the quality of construction is better, if it is not maintained regularly, then it will affect the life of the building. So if it is regularly upkeep and preventive measures means you need certain things which may be required to stem the possible problems. So if you are regularly upkeeping and doing preventive measures, that will certainly increase the life of the building. And if it is not being done, it will reduce the life of the building. Then condition of the environment. So structures which are subjected to extreme weather conditions may deteriorate more quickly. So it may be natural disasters that buildings, where nowadays earthquake resistant buildings are being constructed. Similarly, you need to design the buildings to withstand floods or storms so that their life may extend. If you are not designing them properly, they their lifespan span may be shortened in certain areas. Then uses. So uses, the life of the building depends on the uses. If it rough and tough, if the usage is rough and tough, it will decrease the life of the building. So wear and tear may be affected by the quantity and kind of tenants. Building with high traffic volumes need more regular upkeep. So it will depend upon the building's intended use. Whether you are using residential, commercial, or industrial. So it affects the criteria for durability and design. Then technological progress. So nowadays, many technological lazy things are coming in your construction process. So technological process affect the life of the building, such as method of building method. Using contemporary building methods and technology can improve the longevity and effectiveness. And then materials. There are certain materials which are long lasting that will result in long lasting constructions that can result from advancement in building materials. Then economical elements, this is the thing which is affected by obsolescence, because with the change of time, with the passage of time, the value of the building decreases because of obsolescence. So that effect the obsolescence affect the market demands, means decision on upkeep and upgrading may be influenced by economic viability. Because if you need to maintain the building, if you think it is viable, let us suppose by investing one amount of 10 lakh on the upkeep of the building, if the value increases by more than 10 lakh, then it is viable. But if you spend 10 lakh on upkeep or maintenance of the building and the value increases by only 5 lakh, then it is not viable. So it will depend upon the market demand. Then cost of repairs. Exor- Exorbitant repair expenses may cause negligence, which shortens the life of the building. And then this is your thing you have already studied, that is legal and regulation factors such as building codes, zoning laws, or legal restrictions that affect the life of the building. Then how you can estimate total life, age, and future life of a building, which is crucial for accurate property valuation. You need three things when you are doing valuation. You need total life. What should be the total life of the building? And now, what is the present age of the building at the date on which you are doing valuation? And what is the future life of the building or remaining life of the building? So, total life, this refers to the expected lifespan of the building from the time of construction to the point where it is no longer usable. So is influenced by factors such as construction quality, material use, and environmental conditions. So basically, we take economical life of the building. So we have to check what is total economic life of the building, where it can be used economically viably, with economical viability. So where after that it cannot be used economically viable and valid. So then next is actual age. Actual age is the age from the date of construction. This is chronological age of the building calculated from the year it was built to the present year. Then effective age. So basically, this is the thing which you have to check. So building may be 30 years, age of the building may be 30 years, but it is not maintained properly. It is not upkept properly. So it may seems that its age is 50 years instead of 30 years. So you have to consider the effective age. What is the effective age? This is an estimate of building age based on current condition and utility rather than its actual age. So you have to take effective age into consideration. It can be influenced by maintenance, renovations, and overall upkeep. So remaining economic life. So what should be the remaining economic life? It will be the uh, age which you will calculate by subtracting the effective age from the total economic life of the building. So this is the period during which a building is expected to remain economically viable. So it is calculated by subtracting the effective age from the economic life of the building. So method of estimating future life. So how you can say, first thing is condition assessment. From the condition you can assess what is the effective age of the building. So inspections and assessment of the building structural components, systems and overall conditions help in estimating the remaining life of the building. Then historical data for review historical records and architectural survey can provide insight into the longevity of similar buildings. Then technological tools. So nowadays there are many technological tools such as geographical information system, building information modeling, etc., that can help predict future performance of the building. So based upon that, you can do market analysis. Understanding the economic life cycle in the building's market area is essential. For instance, residential structures typically have an economic life of 45 to 50 years if no maintenance is done. So this is all in our first video where we have learned basic of the cost approach. Thank you very much for listening to this video.